Good morning, Algebra 2. We are going to cover lesson 81 is on natural logarithms. And natural logarithms has like log is L-O-G on our calculator. Natural logarithms. The letters are actually backwards, so it's Ln, natural log. It has an invisible base of e, and e does have a value. It's a repeating decimal. But on your calculator, it should be near the log button. So we are going to go over simplifying properties and how to use it to solve. So I'm going to do a couple with you. So part 1, simplifying. So just like, this is review, just like the log of 10 equals 1, because there is an invisible, and let me grab another color pen, just because there's an invisible base of 10. The natural log of e is also 1 because my invisible base is an e, and so it cancels. The same would be true if I had e to the natural log of e. That also equals 1 because these have the same base. It would all cancel. So we are going to simplify the following, and then we'll try the one in our practice. So we're going to simplify e to the natural log of 3. So because there is an invisible e here, this cancels, and all I'm left with is the 3. So let's try another one. Let's simplify the natural log of e to the 2a squared minus 4. And because there is an invisible e here, this cancels, and we're left with 2a squared minus 4. So let's try our lesson practice, which is on page 576, part A. So they'd asking us to simplify e to the natural log of 3 minus 1. And when I simplify this, remember there is an invisible base of e here, so this cancels, and I'm left with 3d minus 1. Part B asks us to simplify the natural log of e to the u cubed plus u. Same thing, there's an invisible e here, so these are the same, so I'm just left with u cubed plus u. Pretty simple. I wish it stayed that simple, but we're moving on to part 2. So in part 2, we're going to go review the properties of logs. And there are 3. The first is the product property. Sorry, I almost wrote the base 10 log. So ln a times b. So when I have a product, I can write these as 2 separate logarithms by separating it with addition. So it can be written as 2 different logs, and the only difference is I put a plus sign in between. The opposite is true for the next property, the natural log of a divided by b. Instead of separating them using addition, I'm going to separate it using subtraction. So there's that one. And then the last property is the power property, and that states when you have an exponent, it can be written out front and be multiplied by the log. So we're going to rewrite the following as a sum or difference of terms. So we're going to practice. So I think we're on number 3. Sorry about that. So if I have the natural log of 3e over x. So first things first, I notice that I have division. So it's the natural log of the top minus the natural log of the bottom. Then I notice that these have an invisible multiplication, so I can rewrite this first log using the first property to be the natural log of 3 plus the natural log of e, and then I'm going to bring him down, so minus the natural log of x. Then I'm going to look to see if there's anything I can simplify here. And I can simplify this guy here because this is just 1. So my answer is the natural log of 3 plus 1 minus the natural log of x. And that would be the way we would write our answer. Next one. So number 4, we're going to rewrite the following. So the natural log of e to the 5x squared. So the first thing is that power property. So this exponent can actually be written out front. So this is really 5x squared times the natural log of e. And then I have an invisible base e. So this becomes 5x squared times 1 because this is gone. And I'm just left with 5x squared. There's no log, so I'm not going to separate that because the ln is gone. So next one, we're going to rewrite the natural log of 2x cubed over e to the 4th squared. So this is a more complex one. So again, first thing I'm going to do is start on the outside with the power property. So this becomes 2 times the natural log of 2x cubed over e to the 4th. Now I'm going to do the quotient property. So I have 2 times the natural log of 2x cubed minus the natural log of the bottom. So I have the natural log of the top, and then division, look, it almost is like the same symbol. They're both straight lines across, minus the natural log of e to the 4th. So one thing I noticed, these are going to be, this is gone, and I'm going to separate this one. So I have 2 times the natural log of 2 minus the natural log of x cubed minus 1. Oh, sorry, this is plus. Okay, because this became 1. And then the last thing we're going to do, I'm going to bring this 3 out front and then distribute by 2. So my final answer is 2 natural log of 2 plus 6 natural log of x minus 2. And this is 6 because that 3 comes out front. So back to our lesson practice, we're going to do part C. So part C would like us to rewrite for e, real simple one, right? That's 4 times e, so I'm going to write the natural log of 4, first part, plus the natural log of e, it's the second part. And then I'm going to simplify this second natural log because that has an invisible base of e, so I am just left with the natural log of 4 plus 1. And no, you cannot add the 4 and the 1 because the 4 belongs to the natural log. So this is our answer. Okay, d, the natural log of 2x divided by e. Okay, so I'm going to separate the top from the bottom using subtraction. And this has an invisible base of e. I'm going to break the first one up just like we did in part C. So the natural log of 2 plus the natural log of x. And then I'm going to bring down that last part, which is just 1. Part E, the natural log of 8e to the negative x cubed. So let's start with our exponent part. So I'm going to bring that exponent out front times the natural log of, oh, whoops, sorry. Got ahead of myself. I first have to use the product property. So I'm going to separate these. The natural log of 8 plus the natural log of e to the negative x cubed. Natural log of 8 stays, but this has an invisible base of e, so that's just minus x cubed. Part F, the natural log of 5e squared over e cubed, the third. So the 3 comes out front, and then I'm left with the natural log of 5e squared, v cubed. So I'm going to rewrite this to be the top natural log of 5v squared minus the bottom. I'm going to separate this guy, so this is 3 times the natural log of 5 plus the natural log of v squared minus the natural log of v cubed. This is gone, and I'm just left with a 2, so I'm going to distribute the 3. 3 times the natural log of 5 plus 6 minus 3 times the natural log of v cubed. All right. So we're going to do one example, and we only have two more problems. So we are going to work on solving. So I don't know what number we're on. Oh, we're on 6. We're on 6. So example 6. If thallium has a half-life of 73.1 hours. Okay, how long will it take for 1 gram to decay to 0.1 gram? All right, so first things first, I'm going to use the following formula. Give me 5 minutes. I'll be done in 5 minutes. So the following formula is what we're going to use. It's on page 576, and it looks like this. N at t equals the initial value times e to the kt. And so what we're going to do is we're going to start with the half-life of 73.1 hours. So this is saying the half-life, so no matter what you started with, let's say you started with 1 milligram, half of it would be 1/2 times e to the, oh sorry, there should be a negative right here. Negative k, and t stands for time. And they told me 73.1 hours. So we have to solve for k. So in order to do that, I'm going to divide both sides by 1. So I get 1/2 equals e to the negative 73.1 k. Now to solve this, I'm going to take the log of both sides. So the natural log of 1/2 is the natural log of e to the negative 73.1 k. I'm going to use, well, before I use my calculator, we can note that this is going to cancel. So the natural log of 1/2 equals negative 73.1 k. And I would divide by the negative 73.1 to solve for k. So using our calculator, you hit the natural log button, 0.5 divided by negative 73.1, and I get that k equals 0.009. I'm going to round 4 up to 5. So now that I have k, I can now answer the second part. So this gave me k, the first part that we did using this, which is in your book. Now I'm going to answer the second part. How long will it take for 1 gram to decay to 0.1? So using the same formula, it's asking when will it become 0.1. So 0.1, I'm starting with 1 gram. Times e to the negative, now we know what k is. K is 0.0095, and we're solving for t. And we're going to solve for t in the same way we solved for k. So I'm going to take the natural log of both sides. This has an invisible base of e, so now I have the natural log of 0.1 equals negative 0.0095 t, and we would divide by that decimal. So t will equal, and this will be time, so the natural log of 0.1 divided by negative 0.0095, and I got, it's going to take 242.3 7 hours. Okay, so based on that information, we are going to do the last part of your lesson practice, and that is part G. And it asks, how long will it take 200 milligrams to become 5 milligrams if the half-life is 42.3 minutes. So the first thing we're going to do is start, well, and I should have highlighted. We're going to start with the half-life, just like we did in the last one. So they're saying 1/2 is going to exist. Let's say I begin with 1 gram, half of it would be left for e to the negative k times 42.3 minutes. Now, if you remember how to solve, we're going to take the natural log of both sides. There's an invisible base of e here. So I have the natural log of 1/2 equals negative 42.3k. And we would divide negative 42.3. And so k equals the natural log of 0.5 divided by negative 42.3. And I get 0.0164. So I have found k. Now I'm going to solve for this part. So how long will it take 5 milligrams, how long is it going to take to have only 5 left? I began with 200 times e to the negative 0.0164, and we're solving for how long, also known as time. So in this case, I have to divide by 200, and 5 divided by 200 gives me 0.025. Equals e to the negative 0.0164 t. Take the natural log of both sides. And that gives me this answer, right? So I have the natural log of 0.025 divided by negative 0.0164 will equal t. So the natural log of 0.025 divided by negative 0.0164, and I get that t equals 224.93 minutes. So your homework, you are going to skip the following. For homework 81, skip numbers 8, 10, 18, 20, and 23. Thank you.